Today we will learn how we can draw free body diagram from the system which is given to us. Firstly, we'll see what is a free body diagram. For a given body, if supports are removed and forces acting on the body and support reactions are shown, then such a diagram is known as a free body diagram. We'll understand this with the help of an example. Like suppose we are having a sphere which is suspended by a string and resting against a vertical wall. Here this is the sphere which is resting against the vertical wall, and this is the string by which the sphere is suspended, and this is the vertical wall. Here if we want to draw the free body diagram of this system, then in this string tension will be acting, the weight of the sphere which is acting in the downward direction, and also from the wall reaction will act on the sphere which will show it as R wall, and this thing will represent in our free body diagram. Draw a horizontal and a vertical line and will also draw an inclined line because the string is suspended at an angle of 30°. Now we'll just show our reactions. Here tension is acting, in the downward direction weight, and here it will be reaction from the wall. This is how we draw the free body diagram from the system which is given to us. Now we'll solve some examples. Here the angle will be 30° because this are vertically opposite angles. Now let's just solve this example. This system is given to us and we have to draw the free body diagram of A and B. First of all, let's see what are the reactions acting on B. One reaction will act from A. We'll call it as RAB. Then another reaction will be acting from this wall, which we'll call it as BRB. And weight will be acting in the downward direction, which will be WB. Now let's just represent this with the help of our free body diagram. Draw a horizontal line and a vertical line. We'll show the weight in the downward direction. Here it will be WB, and the reaction from the wall is acting at some angle, so we'll draw it inclined. Just draw the free body diagram with the help of a scale. There is no need to use a protector. Here I'll just give it the name RB, and also the reaction from A is acting at some angle. We'll draw that as an inclined line. Here we'll write it as RAB. Let me just extend this RB line backwards. So the free body diagram of B is completed. Now let's see what are the reactions acting on A. As both the sides of the wall are touching A, so the reaction will act from both sides. Like here it will be R wall. Then from this side the reaction will be acting, which we'll call it as RA. Weight in the downward direction, and reaction from B, so we'll call it as RAB. Now let's just represent this in our free body diagram. Here W, here it will be R wall. Then we'll draw an inclined line to represent RA. and this inclined line will be at an angle of 45 degree, because in the diagram the angle between the walls is given to us as 45 degree. Now we'll draw one more inclined line. This will be for representing the reaction from B, which we have called it as RAB, and here we'll show the angle as 45 degree. We have completed the free body diagram of B and also the free body diagram of A. Let's see another example. Here a block A of weight 300 Newton is resting on block B of 500 Newton weight and tied with the wall D by a rope. The block B is resting on the floor C. Draw the free body diagram of block A and B. First of all, let's see what are the reactions acting on the block A. The weight will be acting in the downward direction. Then, as it is connected by a rope, tension will be acting in the rope. Rope will try to pull it towards its side. So in the opposite direction, friction will be acting, which we'll call it as F1. And in the upward direction, reaction will act, which is R1. Now we'll just draw a rectangle like this. Then draw horizontal line and vertical line in order to show the forces. Here tension will be acting in the downward direction weight, which is given as 300 Newton. Here it will be F1, which is the friction, and here it will be R1, which is the reaction. And inside we'll just write A. Below we'll write it as free body diagram of A. On the block B, the reaction will be acting from the block A. Also, the weight will be acting in the downward direction, which is here we'll show it as WB plus R1. And the reaction from the block B will be R2. Then here we are having this force P, which is inclined at an angle of 30 degree. It will try to pull it towards the right, so the friction will be acting in its opposite direction, which is here. Friction will also act from the block A, which we have shown it as F1. Now we'll just draw this rectangle and draw a horizontal line and a vertical line. Here we'll make an inclined line in order to show the force P. And here we'll be showing friction. Due to block A, the friction is F1, and due to block B, the friction is F2. In downward direction, the weight is acting, and in upward direction, the reaction is R2. Also, in the downward direction, we have one more force, which is due to A. So we'll just write it as WB plus R1, which will be equal to 500 plus R1. And below the diagram, write it as free body diagram of block B. Now let's solve next example, which is weight of block A is 200 Newton, and we have to draw the free body diagram of block A and block B. Here, as you can see, both of the blocks are inclined at an angle of 30 degree. First of all, let's just see the reactions acting on B. One reaction will act due to A, then the weight, which will be acting in the downward direction. Here it is inclined at an angle of 30 degree, so we'll have to resolve weight in two components. One is, we'll show here WB cos 30, and here it will be WB sin 30. Here it will be W, and the angle will show it as 30 degree. So we have resolved it in our two components. Then the reaction will be acting from B in upward direction. Also will have to show friction. Just draw an inclined rectangle like this, and then draw a vertical line and a horizontal line. Here the block will try to move in the downward direction, and so will have friction which will be acting in its opposite direction. One will be on B due to A. We'll show it in our diagram like this. Now here RA is acting and W is also acting, which is RA and WB cos 30. Then here we have WB sin 30. In the upward direction, reaction from B will be acting, which is RB. Friction on block B due to A, which will represent it as mu RA, and friction on block B will be mu RB. So we have completed the free body diagram of block B. The reaction on A will be, firstly the weight will be acting in the downward direction, which again will resolve it in two components, as here the angle formed is 30 degree. So it will be 200 cos 30 and 200 sin 30. Reaction will act in upward direction. We'll show it here, RA, and also as it's connected by a rope, so tension will be acting in the rope, which will label it as T, and the rope will try to pull it towards it. So friction will be acting in the opposite direction, which will show it here, and we'll call it as mu RA. Now draw a rectangle and a horizontal line and a vertical line, and we'll just show all of the forces. Here we'll write it as T. Then here the friction is acting, which is mu RA. Here it is 200 cos 30, and here it will be 200 sin 30. Then in the upward direction, we'll show the reaction, which is RA. Inside we'll just write A and here B. And below the diagram, we'll write free body diagram of B. And here it is the free body diagram of block A. So this is how you can create the free body diagram from the system given to you. In the next video, we'll solve the examples based on the Lami's theorem, where it is very much necessary that you know how you can draw the free body diagram of the system given to you. Thank you.